Welcome to the AlphaList podcast. I am your host, Toby. AlphaList is a closed community with over 400 CTOs who share their knowledge and experience in a Slack space and at events. With this podcast, we want to give our members and interested parties insights into the thoughts and ideas of top CTOs. If you're interested in becoming a member of the community, please visit alphalist.com to find out more on how to apply. This episode is kindly supported by Fastly, the biggest challenger in the CDN market. Fastly is pushing ahead the technical boundaries and is, from my perspective, the best solution on the market. Fastly is known as one of the key drivers of the Edge Cloud movement. Well-known customers of Fastly are Shopify, the New York Times, Reddit, GitHub, and many, many more. If you want to try it all with first-class support, just go to fastly.com/alphalist. Welcome to the AlphaList podcast. I am your host, Toby, and today in the podcast, the guy who is responsible for our Germans being able to take summer vacations again and going into holidays and traveling across country borders again. It's Matthias Jugel, the CTO of UBIRCH. And to be more precise, UBIRCH is responsible for the German vaccination passes and like a very time-critical project that he just went through. So I'm happy to have him here. Matthias, that must have been like quite a stressful time in the last weeks, right?
Yeah, that's right. Let's say I didn't have a weekend for about 1.5 months or so.
So how long did it take to develop all that?
To be honest, I don't have a feeling for time anymore, but it was very quick if you take a look at what we achieved. So we launched on the 10th of this month, and we had about, I think, a month or so to actually make it happen, with some time before where we had planning and other stuff and waiting for decisions.
I can imagine that this, like, waiting for decisions and so on, is kind of in public projects a very important piece. And I think you also developed it together with IBM, right? That kind of feels a bit monstrous at first. I can imagine that, especially the project management.
Yeah,
no. Didn't mean it badly, but.
The point is that we as a startup simply are not big enough to get a project like this on our own. So we had to team up with a bigger player, and IBM asked us whether we would like to join. And we happily developed together. So the separation was basically IBM took over the role of communication and also developing the apps related to this project. And since we had worked before already on vaccination passes and test certificates, we took on the backend part, and that's how it came to be.
Okay. Can you maybe tell us a bit more about yourself, like your personal nerd path? I always like to look at that.
The nerd path. So I'm from East Germany. I wanted to be a computer scientist right from the beginning. And when I didn't get a place to study computer science because they didn't want me to. And when the wall came down, I had a chance, and I said, "Now I want to study computer science," and changed to it. And then very shortly after, I went to London to finish my studies. And when I came back, it was right before the big wave of computer scientists being wanted. So nobody gave me a job, and I ended up at Fraunhofer, the big research institution, where I worked for about 14 years. In between, I had 2 startups. Where I basically took a holiday from research and made these startups in knowledge management and other stuff. And I also went to South Korea to do a project there with a very interesting side project where I went to North Korea to take a look at what the computer science is is done there. And when I came back, I went to machine learning. That's how we basically have our connection at the Technical University of Berlin, and started a project doing real-time data analysis together with a friend. And after that, I started UBIRCH with Stefan Noller. And that's how it all came to be. So I did it basically a long way that through research ended up in being self-employed.
And issuing vaccination passes.
Issuing vaccination passes, yeah. Actually, the vaccination passes are a lot about crypto. And at UBIRCH, we wanted to do crypto without the human part, because that's always the hard part, because we wanted to encrypt and make data verifiable in machines or from machines, because machines don't ask you all these questions. And now we have a project where a lot of humans are involved.
Sounds impressive. I mean, or let's say sounds hard.
Yeah, especially since crypto is very often very difficult to explain because it happens under the hood. You don't see it. So there's this security that you don't see. It's not like a key that you can put into a lock and open something.
Yeah, I think, or what do you think? How many people actually understand what they get when they see the vaccination passes?
I don't know, maybe 10% or so, very, very little. And they know that they have something in the hand that allows them to travel or do something with it. But how it works is not easily explained. Even to people in the tech scene, sometimes it's difficult because of the layers that are involved. So you have data formats, you have algorithms, encodings, and then in the end you have something printed on a piece of paper, which somehow translates into these complicated things.
Yeah, and you can still copy it and so on, which then sounds a bit weird.
Yeah.
But it's not if you really think about it. Can you maybe explain it? Like, how does it work? How does the German vaccination pass work?
Well, the German vaccination pass is actually something that is not a German invention. It's defined by the European Union because all of the member states need to implement it. And I can explain how the European Union wants it to be. So basically, when you get your shot, you create a little data set with your personal information, your name and your birth date, for example, and also some information about the actual vaccination, which is, I don't know, the product of the shot, like the manufacturer, the date when you got your shot, which shot in a series of doses it was. This is simply a data set. And the EU defines how it's then handled. It's basically put into a binary representation. And this binary representation is then signed using a cryptographic key material. So when you know the public key, you can verify that it's authentic. And then everything is packed up in a little bit of, let's say magic. It's actually the binary stuff is compressed and then encoded in something called base 45. An encoding I never heard before, but apparently it's very efficient in combination with QR codes. And then you take this text representation, base 45, and put it into a QR code, and the QR code is printed, and then you have your code.
So it's like a JW token in a way, which is
it's very similar,
encoded and just a bit smaller, or?
It's probably a bit smaller because JWT is encoded base 64, and it's also represented purely in text, and it's not compressed in itself. And it cannot contain as much information in the same amount of data, basically. So it would get very big in the end.
Okay, and what did you actually do? I mean, you're generating those pictures, or what do you actually do?
No,
I guess you
So someone has to take care of taking the data set and then creating the actual signed piece of data. So what we do as a service to those giving out these vaccination passes is they give us the data, we transform it, sign it, and then hand back something that can be either printed in a QR code or printed as a PDF document. So we also create PDF documents.
So if I would now, let's say, inspect the traffic of my German Corona app when I try to get such a certificate, your servers would be involved in a way, and there would be a service No.
This is all done in the vaccination centers. So the Corona, the app that you use with your vaccination pass is basically doing everything on the phone. So that's a very important part that the EU defined, that they said everything must be verifiable offline. So these apps basically get the public keys and verify the signature, and then they present you the content of the QR code, the data that's actually in there.
Okay. So that you can, like, everyone can validate it with a phone without an internet connection and so on.
Basically, yes. The question is still whether you're allowed to do so, because this is kind of a question of jurisdiction. I think it's probably more relevant for people at the border, border control. They will have an application that can actually check that your QR code is valid.
So it's not public. So there's no public app that you can use to verify it.
There's an app in the App Store, but I'm not sure it's really useful for everyone, because it's also, you check it and it tells you something is valid or invalid, but it doesn't give you much information about anything related to the actual content of the QR code.
So it doesn't print out the name and the birth date?
No. Okay. Because the idea behind it is to be to present as little personal information as possible.
Okay. Because I was yesterday sitting at the hairdresser and asking him, okay, if I show you my vaccination pass now, what do you do with it? And he said, I don't know. I actually look at it. And if it looks okay, then it's okay. And I just thought, okay, wouldn't it make sense to have something for, like, if I'm a club owner or something, or restaurant owner, for me to validate if it's really, like, proper?
Mm-hmm. I think this is a misconception that the EU didn't define all this for the hairdresser next door. The basic idea behind this is to allow free travel in the EU. So what we talked at the beginning about the holiday, and that makes it much more clear that it's more important when you cross a border and when you are checked abroad by police or by somebody who would like to know whether you're allowed to be there. So it does make sense that the verification of these codes is done by an authorized person instead of everybody.
Okay. And in Germany, the passes are issued by the vaccination centers. That's what you just mentioned. And by pharmacies, I think. Like in one of the pharmacies close to my where I live, there's actually a queue in front of it now, all of the time, every day. And I think that's because they issue those certificates, right? Do they have then? Does every pharmacy then have like a public key and a private key to actually sign or generate the certificates, or how does that work?
Well, that's one of those questions. I will have to point you to the Ministry of Health to ask these questions, how this is actually done, because these are the details of the system that unfortunately I can't speak about. I mean, we do something similar in a different area. So when you go to your hairdresser or to someone you would like to go to the theater or so, you need probably more than the vaccination pass, because it's always the question: is the vaccination pass actually sensible for every use case? Very often it's much more interesting. Do you transmit the disease? And to check this, it's much more useful to do a test. That's why all these test centers are there. And we as a UBIRCH, we also developed technology back last year when the whole thing began, to make these test results verifiable. And this is much more interesting, and to also try to make it in a kind of technology, or put it into technology that's easily verifiable for everyone. So it's, for example, if you do a PCR test, the lab gives you back a QR code as well. Looks very similar, but it's a little bit different, which is then verifiable by everyone. But they just scan the QR code, opens a web page, and then we do some check whether this data that's encoded in the QR code is actually a valid test result. This time it's not offline capable. We do some online check, because then it's easier to check whether we have seen this before, was it at the right time, and things like this.
Okay, interesting. But coming back to the queue at the pharmacy, I hope it's not due to the load on your systems that the queue is there. I can imagine that, especially when launching it, that there must have been some heavy load patterns on your systems. How did that work out, the whole launch? I mean, it's in a way like an event you can't postpone. You can't change the date of that launch date. It must have been like a bit of a scary moment, right?
It is, of course. Of course, we scaled the system in a way that we can handle load like this. But sometimes usage patterns are not foreseeable. So it's very hard. And you can think about how many pharmacies there are in Germany all over the place. And they basically started at the same time to work with us. But I think the queues are probably more to being able to handle all these people trying to get their pass. I mean, you only have like 2 or 3 people in a pharmacy, and they have like 50 people waiting in front. It takes some time to ask them, check the vaccination pass, the yellow ones, then enter the data, and then print it out. That's probably a little longer than it takes for us to actually generate the actual vaccine certificate.
So are you allowed to tell us how many people per second actually try to or actually get such a certificate?
No, I'm not, but I can tell you, which is already known. From Merkel already told us 30 million vaccine certificates were already handed out. Over 30 million.
So I can imagine, like, especially the first days, it was, or the first week, it was a lot, right?
I think it's quite a lot for the time being since we started.
Okay. So it's actually an interesting thing that you did there, and the standards that you used for example, other use cases like event tickets, for example, right? Mm-hmm. To verify event tickets. Do you see that this is like a thing that will come, that certificates like that are being used for, or mechanisms like that are being used for event tickets and so on too?
I think so.
Okay.
I mean, it's something we are in talks with ticket sales companies, because they are, of course, interested, not only in combination with health passes, but also in general. So it's always the question: you hand out a ticket, you must make it unique, and you have to invalidate it as soon as it's used. And one nice part of the technology that we usually use, the blockchain, gives you the ability to actually do so. So you can register something that it's being, for example, that I sold you a ticket, then you can run around, and when it's used, we invalidate it by also marking it in the blockchain, and we have a very nice record that this happened. And there are also ways to make these tickets hard to copy. One way usually is that you have to combine it with personal information, so you have to show your passport or your Ausweis, or you use a hardware piece. like I don't know, an NFC chip or something like that that you bind to the actual ticket, then it's very hard to actually invalidate or copy it and use it twice.
Are there other ways to I don't know, have QR codes that change every second or stuff like that? Is that something that makes sense, or doesn't it make sense?
Now you have to always think about the medium the QR code is on. So a QR code is printed on paper usually. I mean, you can have something that you have in your phone, but then you need an app. And people like a piece of paper in their hand that they can use as a ticket. And then you have to make sure that this is something that you can verify that it's actually the right thing, even if you copy it. So you have to usually combine it, as I said, with a second factor. In general, what we do with data sets in different areas, like in the industry, we do something similar. So, for example, you have a sensor out there. So, in one case, we did something in the area of the insurances. So, for example, you have a sensor that you put in your car, and when you drive, it records how well you drive, whether you had acceleration spikes, whether you had a car crash or something. It's very important for one that you know that the sensor data actually comes from this piece of hardware that you have in your car, and that it's not modified. And we did that in a case for an insurance company to test whether they can put it in the car, and then additionally you had to use your phone next to it, and then sometimes the phone would query the data from the device, and that way you could verify that the data is actually from this device. The device is bound to the user, so to the driver, for example, and this makes it possible that when something happens, you don't have to involve a lot of people or experts to actually check that this car crash actually happened or not. You can trust the data because you can look at it. You see that, we always record when we saw some data. So it's very hard for the user of this device to actually fake, for example, time. And it makes a lot of processes easier in the industry.
Thanks a lot to my friends at Sastrify for sponsoring this episode. A lot of CTOs I know are responsible for procurement of software as a service by accident and never have the time and energy to work on optimizing their costs. For example, at my company OMR, we have a lot of tools: G Suite, Adobe Creative Cloud, New Relic, and many, many more. Sastrify helps companies like ours to optimize the costs and negotiate with suppliers of such software. In our case, they helped us to save around 20K per year, which is a lot if you look at our company size of around 150 people. It is a simple and hassle-free process we went through, and I can just recommend anyone listening to do the same. They actually promise to save more money than they cost. They are already working with a lot of AlphaList members, such as Runtastic, Westwing, or Emma. To get started using their services, please visit sastrify.com/AlphaList. Just check the show notes to get the link. You'll get a 50% discount for the first 3 months in addition. You mentioned beforehand that you typically use blockchain in your projects. Like whenever you followed the press, I was a bit sad to at a certain time read, okay, no, they don't use the blockchain, because I thought it's like a perfect use case for blockchain. Why did you derive from that? Because of the time-critical manner, or?
That's we developed the project together with our customer. And why the customer didn't want the blockchain or why he does want the blockchain is up to himself. So this is, again, a question where you have to ask our customer, in this case, the ministry, why they didn't want to have the blockchain. It's something, in the end, we make a suggestion, but in the end, they have to decide what they would like to do. We never know what's going to happen, what's coming up. In other use cases, we do use the blockchain a lot. In this case, we don't.
Okay, but like time-wise, it would have been possible. There's no like extra time that would have gone into the blockchain implementation, or?
No, because this was technology already in place. I mean, we had these vaccination passes we did for 2 areas in Germany. And there we basically used this technology. In Altötting, for example, we had a little web form that we provided to the people in the vaccination center. They entered all this information that I talked about before. We would take this information, hash it together with a salt. So it's basically anonymous for us. And this hash is then sent to our backend. And we anchor this information in the blockchain and then create out of the actual information in the vaccination center a URL with all the data. So you get a QR code where you actually see all the data that's in there. And if someone wants to verify it, they decode the URL, create the hash again, and then send it to us. And we tell them a piece of data with the signature, so they can do a signature verification. And we also tell them when we have seen it, so you know it's actually a vaccination at the right time. And you can check all this and make and be very sure that it's the right thing and not something that's faked.
Okay, but the blockchain then means or the decentral nature of it means that you have a cluster of computers that hosts the software, and then they replicate the blockchain from each other, or how does it?
Yeah, that's a bit of a misconception that's always coming up in terms of our use of blockchain. So we do a mixture that tries to use blockchain as a tool, and we do have a few proofs that we would like to provide to our customers. One is the data is authentic, so we know where it comes from. That's normal crypto signatures. The second one is that it's unmodified. That's also the signature in the normal crypto. Then when has this data been generated? This is something we provide through the blockchain. So basically the data flows into our system. We only record in our local database, basically the hash. And then this hash goes together with a lot of other hashes from other customers together in a very big Merkle tree. And the tips of these Merkle trees, the roots of these Merkle trees, those are the ones that are actually ending up in a public blockchain. And it's where also these 5 blockchains came from. So we don't only store these, let's say, root hashes in one blockchain, but in multiple, because there are a lot of different blockchains out there. Some are very fast, some are very slow, some are very expensive. And we would like to be sure that we always have a proof that at a certain point in time, a piece of data was generated. And additionally, we also have a proof of order and completeness. That means that the data where it's generated is also connected to each other. So each data packet that's generated is then connected to the one before and the one after. And all these proofs together, a part of that is the blockchain, a part of that is the crypto that we use in its own. It generates basically our business towards the customer.
Okay, so that means that you use public blockchains, so like Ethereum and others
Yes.
potentially to actually store those hashes, and your private infra to store the real content, right?
Correct. But we never see the content of the customer. We always only handle hashes. So the customer is the owner of his data, and we only record for him a fingerprint of the data, and we make sure that this fingerprint is then also locked in time and space, basically.
Okay, interesting. If I want to play with that, is it your recommendation too that I look at the whole Ethereum ecosystem, or where do you get, how to get into that crypto world? I think it's kind of, it sometimes feels like you're standing in front of a mountain and looking at a big mountain and not really getting into it. What is your recommendation?
I think the best way is to start with actual cryptography. So try to get to know how to create a signature, how to encrypt stuff, how to decrypt stuff, how to verify signatures, and then play with it. Things like how to create a connected hash list. That's something that's the basic of most of the blockchain and distributed ledger technology is bound on actually creating hashes of data, fingerprints of data, and then connecting them to each other. Because when you create one of these linked hash lists, it's very hard to break them without breaking the whole system. And that's basically what the blockchain is about. If you break one link, then you break the whole thing. And that's why it's so important that you distribute it. So a lot of people have a copy, so you can recreate a thing. And you also can detect when something is broken. Okay. And then when you're there, then you go to the next step and take a look at how blockchain works, because a lot of blockchain and distributed ledger technology in the end is a lot of infrastructure, more than the actual crypto in it.
Yeah, I can imagine. I mean, in a way, it's like a master replication, like a very very distributed one, right?
Exactly.
And that's when you actually, like for such cases, you actually use it, right? When a lot of people need to write and need to verify that the information is correct. So what is then, like if you look at your company, I guess you mostly do consultancy, or do you also develop proprietary technology for such cases like the test centers and so on? What would you say is your secret sauce as UBIRCH?
I think the secret sauce in the end is that we provide technology around blockchain, so security as a service. We try to make it easy for our customers to use it without having to think about it. And the magic here is that, and that's very similar also to the healthcare cases. The digitalization in healthcare and also in the industry is sometimes very difficult because you have established data paths. So there's data flowing from A to B in a very hard set way. And it's sometimes difficult to actually go in there and say, okay, we have to secure it. We have to add signatures to it. It's in many cases, it's not possible. So, and what we do is we tell our customers, okay, you don't actually have to change anything in your data flow right now. All you have to do at certain points where it's important for you, you take these fingerprints of your data. You get a client from us, a little piece of software that you just put next to it. You look at it, take a fingerprint, send it to us. We make sure that we store that we've seen it, that it's unmodified from there on. And then and when the data flows on at a different point in time, when you need to verify it, you then take another piece of software from us and just recreate the hash, the fingerprint from the data, and then check whether it's original and authentic. And the interesting part here is that we basically create some kind of bypass that so the security flows outside of the actual data flow system. And you always have access to it. So at any point in time, you can access the security and verify that everything is correct. And the interesting feature of this, that it works over borders. So usually within your own system in a company, many of people will say, okay, I'm sure that everything is correct. And when I have a hacker in my system, I will know. But this is not true, for example, if one company has to talk to another company and if they have to transfer data. So, for example, a manufacturer creates data for the manufacturing of a certain piece of product, and then they ship it. And they also would like to ship the conditions under which this product was created. Just think of chemical industry. Sometimes a compound product has to be created under a certain pressure and temperature regulation. And you have to, and this very often this is recorded. And the record of this is something you also give to your customers. And then the customer can take this record and verify that it's actually authentic and fits to the data at all that they got with the product. And this is how, this is transitive. You can do this in many steps from there on without actually having a lot of impact on the original data flow, how you transported the data before to your customers.
So it could make sense to verify vaccination doses as well, not only vaccination passes,
exactly.
Right?
Yeah, this was actually one of our first ideas, and we talked to the pharma industry as well, because this is a big issue. How do you verify that the production of the doses is correct, that they have been transported at the right temperature all the time? All this needs to be recorded and be verified at some point. And this is a perfect case for blockchain technology. However, directly using blockchain can be expensive and complicated. And that's why we try to make it as easy as possible by having some kind of a simple API that the customer can use. They just put the data in and then we take care of everything.
Okay, cool. And do you think that this will actually, like 10 years from now, where do you think we will be standing with blockchain? Do you think we somehow at a certain time have our passports in a blockchain somewhere, or when do you think like adoption will really start for like government use cases?
I think they're already starting. So, we already see a lot of, at the moment it's pilot projects, especially in the area of self-sovereign identity, where this is a very common case. It's very interesting to see that you don't actually have a plastic card anymore as a passport or a little booklet, but basically have it on your phone. And then you also have the option to present only the information that you want someone to see. For example, in my case, it would have been interesting, when I lived in South Korea, I also had this trip to North Korea. And the problem there is that it's a bit of a complicated thing to explain what you do in North Korea when you go back to South Korea. So, and it would have been nice to have a way to not show that I have a visa for North Korea in my passport to the authorities in South Korea. I ended up having 2 passports, which is also a way that you can do. But it's kind of with self-sovereign identity where you could show, okay, I'm this person and I'm allowed to be here. I have a visa, then it would be okay. But all the other stuff in my passport would not be visible. That would be a nice thing. And I think this is the perfect use case. So you have your data under your control. You have some markers in a distributed ledger system that prove that this is actually the right thing. And then you can transmit it whenever you need to and you want to.
Okay, yeah. I once was experiencing a similar thing when I traveled to Israel. I think that is also quite helpful for that. Okay.
Yes.
And so it's like 10 years from now, we all have digital passports that are purely digital on our phones. And okay. Yeah, looking forward to that. I mean, still carrying all that paper somehow feels weird, right?
Just think of how much stuff you already have on your phone and where you don't use a piece of paper anymore. And this is going forward.
And then we still need the second factor somehow, right?
That will be very important, yes. The question is, what will it be?
Is it like your face or your fingerprint or something like that? Or what is it ideally from your perspective?
I think the safest way is still some kind of PIN number in your head. It must be long enough, of course, because there are a lot of technologies that make it possible to use a photo for something like, so your fingerprint, sometimes very hard. You have to identify that it's actually a living finger. With your face, it's the same. I mean, most phones now have something like a liveness check. So they look at whether you are actually a person and not just a photo in front of the camera. And it's a race in the end. It's as secure as it always is. There's a race between those who try to break it and those who try to improve it.
Okay. So stepping back at your, in a way, rat race with finishing this project, is there any favorite failure moment you want to share with us, and you are allowed sharing with us? Any moment where you said, "Oh no, this is not gonna happen"? Was there any moment?
Of course, I'm not allowed to talk about it, but when you create a system like this, it's not always foreseeable what's going to happen. And it was out there that it didn't always go very round. But most of the time, I'm very happy it just works. And it's running very, very nicely right now. I think we got over the first launch issues that you usually have when you launch such a system, that you've never really tried with the amount of data as we have it here before.
I can imagine it's like an event you can't postpone, right? It's
yeah. Actually, in the first nights, I couldn't go away from my computer. I just watched the dashboards and see what's happening, whether something breaks. But fortunately, it's running really, really good. So I'm very happy about it.
Okay. Yeah. Great. And great that you actually help us to travel again. And that's, I think,
it's my pleasure.
Like, at the end, it's a very, very positive project, right?
Yeah.
If it doesn't like fully crash all of the time, and after a few, you get over the first days of stress, I think.
Yeah, and to be honest, I mean, if you look at it, I think it's a very nice project to show. And I don't want to brag, but it's a project that shows that digitalization in Germany is possible, and it can be done in a way that just works. I mean, we had the Corona Warn-App before, which is a little different because it started as an app. But both projects together show very nicely that we can do and improve our healthcare system by digitalizing it.
Yeah, it still feels like we are sometimes a bit slow or careful with really pushing it in the market then. I mean, with the Corona app, it could have been, let's say, after a few months, we could have been more pushy that people actually use it. But yeah, I think that's something that hopefully with now having those two projects, it hopefully helps for also the government to see that or to have more trust into such digital things, right? Because it simply makes sense that, and it's simply safer than having a sheet of paper somewhere in the restaurant, for example,
Definitely.
where people write on the names and everyone can read it. It absolutely makes sense.
With the positive feedback from those projects together, I think we made a big step forward.
Yeah. So the digital health insurance card will come at a certain time.
I'm sure. I mean, with the beginning of next year, we will have the EPA, the elektronische Patientenakte, the patient record, and many of the Germans already use it because the healthcare providers are pushing it using their apps. So I think we make progress.
Great. So I still have a little surprise for you. I also know your co-founder, Stefan. He's the CEO of your company. Also quite a nerdy guy, I think. And he gave me a private key that I can use to actually generate vaccination passes myself. And I kind of found a hidden feature in your software there, which is called the time machine feature. And we now have the pleasure to actually test it out and actually jump back, generate a pass that lets us jump back in time for just 2 months. And we now have the chance to observe yourself coding in a very, very early phase. And like the first version of the vaccination passes and the time machine feature. And you now have the chance to whisper something into your 2 months younger ears. What would it be?
Sleep more.
What? Eat more or sleep more?
Sleep more.
Sleep more.
I need more sleep. Yeah, that's really the thing in a project like this under such a pressure. It's very important to actually eat and sleep more. You know, sometimes I forget even eating, and then my family just hands me stuff into my office, so I don't starve. And I think many of my colleagues have the same issues. It's an unfortunate side effect of a pressure with this of a project with this high pressure.
So Thanks a lot, Matthias, for joining me in the podcast. I hope you get enough sleep now and you're able to eat a bit more again. Looking forward which crazy crypto projects you're up to soon and how UBIRCH develops. So fingers crossed for the future. Maybe you do the E-Personalausweis at a certain time or something like that. Looking forward to that. Fingers crossed and talk to you soon. Thanks.
Thank you.
Bye.
Bye.